So in this video, we're going to look at the second and higher derivatives, and again, it's going to be like more of an explanation-y type video. We're not going to go through any specific examples, but we will have a look at some sort of like some smaller ones, which don't require us jumping to one note. Okay, so the second and higher derivative. So the derivative of a function is another function. Okay, so no matter what function you take a derivative of, it's going to, in return, give you a function back out. So in turn, it can be differentiated as well to give the second derivative of the original function. So the way we write this, so if f of x goes to f dash of x for the first derivative, then this goes to f double dash of x, which is the second derivative. Okay, and in our new notation, dy dx, so we get y, which goes to dy dx. Okay, so it's a d, not a delta. And, not equals, because it's not equal to it. And this, in turn, can turn into... now, I need to make sure I get these around the right way. It's d squared y over dx squared. Okay, like that. And that's our second derivative. So this is function. This is first derivative. And this is second derivative. Okay. So the second derivative is just differentiating the first derivative. Okay, so... which is a function, so we can do it. So let's have a look at a small example. So, for example, okay, let's start off with the function, okay, x to the power of 5 plus 5x cubed, okay? So using our new function, our function notation, we get f of x is equal to x to the power of 5 plus 5x cubed, or we could write that as y is equal to x to the power of 5 plus 5x cubed if we wanted to draw it. Now, the first derivative, f dash of x, is equal to 5x to the power of 4 plus 15x squared, okay, using those differentiation rules where we take the power down to the front and subtract the power off. In our new notation, that's dy dx is equal to 5x to the power of 4 plus 15x squared. I need to make sure I'm saying this right. Now, the second derivative of this, so f double dash of x, okay, well, that's equal to, so take the 4 down to the front, and we get 20x to the power of 3 plus 30x, okay, and using that new notation, we get d squared y over dx squared, and that's going to be equal to 20x to the power of 3 plus 30x. Okay, then this process can be repeated indefinitely to find third and higher derivatives. So f double or f triple dash, okay, is usually the next one we go to. So that's going to be, take the 3 down, we get 60x squared plus 30. So the x becomes x to the power of 0 and the 1 comes out the front. Or this is going to be d cubed y over dx cubed. And that's equal to 60x squared plus 30, okay? Continuing this pattern on and on, okay? We're not going to go away from the dashes now, and what we're going to do is we're going to go f of 4 of x. Okay, so that's equal to 120x, okay? Or d4y over dx4 is equal to 120x, okay? F of 5. You can see where this is getting at, okay? So it's eventually going to get to 0. And last but not least, we get... Okay, and it gets to 0. So that's basically how low we can go. Now, the other thing that we're going to talk about is the operator notation. So let's say that the derivative dy dx can be, the derivative dy dx can be regarded as the operator ddx operating on the function y. This gives us alternative notation for the derivative again. So what we could say is, if we've got x to the power of, well, that's not a 5. If we have x5, then what we can do is we can say, okay, well, we're going to apply the differentiating operator, ddx, on x to the power of 5. And that's going to give us 5x to the power of 4. Okay, so it's nothing too complicated. And, we could do this again. dt dx of x squared minus x plus 1, okay? Well, that's just equal to 2x minus 1. Okay, so it's just a matter of, you know, saying that this is a new operator that we could do, okay? So the standard rule of differentiating, oh, that's not a R. Now you remember this from the function notation, but we're going to use our new form. So it's going to be d dx of x to the power of n is equal to nx to the n minus 1. Okay, so again, we take the power down to the front and we subtract 1 from the power. Okay, so that's basically all there is to this video. Okay, it's just saying that, you know, we can differentiate more than once, and we've got these cool little things that we can, like this new operator we can use. So think of d dx as like, you know, we're doing sine of x to the power of 5 or something like that. So it's just a new rule that we can use. It's a new function. It's a new operator that we use. Okay, and that's for all real n. So with that being said, that's going to be the end of this video. And what we will do after this is we're going to have a look at some more in-depth examples of how we can apply this to questions.